Monkeys in love, monogamous monkeys. Monkeys where the males are some of the most committed fathers among all mammals in the world. Like for example, the group of all monkeys that you're seeing on the top left corner of the picture, sitting on the top of a tree in the forest of Argentina. Or the pair of teething monkeys from the Amazon forest of Brazil, Ecuador, Peru, at the bottom photograph, were giving their early morning duet. We call them pair living, we call them socially monogamous, we call them pair bonding. What happens is that anywhere you go study them, anywhere you find them, in those groups you only find one adult male and one adult female. And that male and that female spend a lot of time together. They're going to travel together, they're going to eat together, they're going to sleep together. They show an awful lot of synchronicity in their behaviors. They even share in parental duties. They are going to coordinate their care of the young. That's why we call them socially monogamous pair living. Now, this is unusual among mammals. This is unusual among primates. We're all familiar with the idea of mom and dad sharing in the care of the chick. Those are penguins. You may even have heard about the amazing stories of the seahorse male who gets pregnant and delivers the baby seahorses. These are fish, these are birds. But I'd be impressed to find somebody who's seen this, if not in a cartoon. You have not seen a cow cuddling with a bull and taking care of the calf. And you'll be hard-pressed to find cats and dogs doing the same. It is unusual in mammals to see pair bonding, pair living, monogamy. And we think that part of the answer lies in what we describe as typical mammalian reproductive biology. There's something about mammals that conditions those kind of social relationships. To begin with, mammals, female mammals, get pregnant and lactate. That's something that males don't do. And the pregnancy, the lactation, is going to condition which of the two parents can really interact in an important part of the life of the infant with that infant. But it isn't just pregnancy lactation. There's also internal fertilization. In mammals, the male has to get his sperm into the female tract to conceive, to fertilize the egg. That may not happen in fish. That is different in birds. That internal fertilization, in turn, sets the stage for the fourth description that I have there on this slide that we're going to come back later. There is father uncertainty. The male who has sex with a female among mammals cannot be sure that he has actually sired, that it is his sperm that have conceived the egg. So whenever he interacts with the infant, there's some uncertainty to father mammals. So these are some of the questions that I have explored over the years, almost 3 decades, first as a behavioral biologist, now also as a biological anthropologist. I'm trying to understand the evolution of love, the evolution of pair bonding, the evolution of fatherhood, as it relates to us, to human beings today, and to understand what we did today, I look into the past. But it's very difficult to look into the past. Human behavior doesn't fossilize, doesn't really give us a lot of cues. So we have found a window into the past, which is the study of non-human primates. And that's what I've done all these years. And I have focused on a number of monkeys. I mentioned the teething monkeys, I mentioned the adult monkeys, that are pair living, socially monogamous, sexually monogamous. They also are pair bonding. They establish a bond between them, an enduring, long-lasting emotional connection between the male and the female that we're going to come back at the end. We think it's a very important component of the existence of these social relationships between male and female monkeys, between male and female adult monkeys. So let's now go actually to one of the sites where I work to understand pair living, monogamy, and fatherhood. And this is the northeastern part of Argentina, in the province of Formosa. We've been working there for almost 30 years in Estancia Guaycomé, a cattle ranch, 25,000 hectares, that's about 75,000 acres. And we have a reserve, Reserva Privada Monomiliquina, that's how we call the monkeys in the area. And over the years, we've developed a rather sophisticated system of trails that are shown in the slide with those kind of crisscrossing of yellow paths that allow us to find, track and observe the young monkeys. Of course, the job is made easier because over the years we have succeeded in capturing young monkeys and feeding them on the neck with a little transmitter that produces a signal that then with an antenna we can find and allows us to track them. That has allowed us to study many of those groups that I described initially. I am showing you here 18 peer living groups, 18 socially monogamous groups that occupy a patch of forest. We call it territory. They don't really share it much with other groups. Think of it as your neighborhood, right? Each one has a little bit of forest where they have all the resources they need. Food, drink to sleep, shade, whatever it is that they need. And in each of those groups, as illustrated by the diagram, just one male and one female, which are doing all of their stuff all along together, and some young. So that's what we know about how they're organized socially. This is a slide showing you an adult male that's transporting twins. Twins are unusual among adult monkeys. Only a few times we've seen them born. And so we didn't know what would happen because normally the male takes care of the singleton that is born. But in this case, twins were born. And the mother did not contribute any more effort, which is already very tiny, compared to what she was doing with singletons. The twins did not survive, so we think that maybe the father couldn't handle them by his own. And the male does pretty much everything. The male transports the infants, shares food with the infants, plays with the infants. If the infants, as they grow up and they start exploring around, they find that suddenly there's a little bit of a gap in the forest, and we're trying to go from tree A to tree B that's larger than usual, they may give a distress call. Who comes to the rescue? Dad comes over his back, infant jumps on, and they go across the gap. So it's primarily dad that provides almost all care except for nursing. We know that this is working in evolutionary terms. We know that there are adaptive benefits to the system because in adult monkeys, this system of biparental care leads to very high infant survival. As many as 87% of the infants survive. That's a very high number for all kinds of mammals and primates. So we take that as evidence that that's a piece of evidence speaking of an adaptive value to having both parents care for the young, because you do not have those survival rates when it is only one parent that takes care of the young. So what I described to you, kind of a love story of pairs of monkeys in love, sharing a territory, being nice to each other, and raising kids together. But that's not the full story. What we learned over the years is that those young that are born in a group with mom and dad clearly cannot have babies with mom and dad. They need to leave their group. And they need to go live and find another partner with whom they can settle down, have their own yard, and their own family. When that happens, these young adults, now they have their hormones raging, they are looking for partners. The way they find a partner is challenging resident adult males and females. And that gets ugly. There's a lot of disruption of the bond of those pair bonded adult monkeys we've been talking about, because now we have a challenger. In a young adult male that may be challenging the resident adult male, or a female challenging the female. The picture on the left is showing you an animal missing a finger. We see them missing fingers, we see them missing pieces of their earlobes, as the picture on the right. We see them falling from the trees because of fights. This sometimes has awful consequences, including death. And this could have been both a male or a female. They get kicked out, they get kicked out through aggression, somebody moves in. Now remember, we're coming from the beautiful story of the family of mom and dad having kids. Now mom or dad have been kicked out. Now you have a stepmother or a stepfather moving in. That changes completely family dynamics. And so the question is, first, when we're looking at the males providing care for the young, are they really the biological fathers, or are they stepfathers? The next slide will explain us that if we have biological fathers, we're talking about genetic monogamy. If we only have stepfathers, maybe there's sexual monogamy. Male and female are having sex with each other, but not necessarily always siring offspring with each other. We refer to genetic monogamy when we can confirm that not only they're having a good time together, having sex with each other, but they're only reproducing with each other. And for making an evolutionary argument around some of these patterns being adaptive, we need to show that those animals showing those behaviors do better in terms of producing offspring. So for that, we needed to get some genetics. And so our monkeys are the first mammal, the first primate, where we have found genetic evidence that they have sexual monogamy. We looked at 126 infants. This is a huge sample size of which we're very, very proud, and never did we find any genetic evidence that the male taking care of the young was not the biological father of the young. So they're having genetic monogamy. So the care they're providing makes sense, because now they're taking care of their own young. But I also told you that sometimes young find themselves in the presence of step-parents, stepfathers and stepmothers. So we wanted to look at how that affects the fitness, the success of the parents. So I'm going to show you now some data documenting the effects of losing your mother, your father, or neither of your parents. We start with the baseline. That graph is showing you the relative risk of death when you have both biological parents, which is roughly 70–80%. And we're going to compare that to what happens when there's loss of the mother. We see that there is a movement to the left. Survival is reduced when the infant loses the mother. What is fascinating for a mammal, given all I told you about the reproductive biology, is that when they lost the father, the drop is even larger. So we see a survival rate that drops from 71% to 55% when the infant loses the father, much more substantial than when they lose the infant. Again, speaking of the importance of having both parents and primarily the father. So just to close up some major key points, trying to go back to the main questions that have driven my research, trying to understand human evolution. So clearly, when you have peer bonding, when you have peer living, you're increasing father sovereignty. Why? Because male and female are all the time together. They're synchronizing their activities. And that also increases the exposure of fathers to infants, which probably prepare them to develop a bond with that infant. That is promoting paternal care. And we have data suggesting that paternal care increases infant survival, therefore that results in an increased reproductive success for both parents. But we still have competition with these young adults that we call solitary floaters. That has a negative effect on the relationship between the pair-bonded adults. It has a negative effect on the infants, and therefore it has a negative effect on the reproduction of the original pair. Even in the face of this disruption, the almonds are resilient, because what's been fascinating is to learn that very much like it happens in so many human societies, following the loss of a pair mate, individuals may repair, may reestablish a new bond, and may have infants with their new partner. So that's speaking about the resilience that exists in this system of peer living, monogamy, and fatherhood. With that, I want to finish by thanking the over 400 students and colleagues and volunteers who have made the research possible over all these years, and all the funding agencies that supported our work. Thank you.